Everyone. In today's lesson, we are going to talk about our first type of special right triangle. So our first special right triangle comes from isosceles right triangles. So these are called 45, 45, 90 degree triangles. And that's because we have one right angle, which is 90 degrees. And because this is an isosceles right triangle, we know that the two base angles are going to be congruent. All right, I'm going to label these angles A. So if I wanted to solve for the measure of angle A here, A plus 90 is going to equal 180 degrees. And if I solve this here, 2A equals 90 degrees. Each of these angles is 45 degrees. Okay, so that's how we get this 45, 45, 90 triangle. Okay, these are referencing the angles to that right triangle. Now, in this right triangle, we have our legs. So we're going to have two legs. And because this is an isosceles triangle, we know those two legs are going to be congruent. And then we have the hypotenuse of our right triangle, which is that side across from your 90 degrees. It is the longest side of a right triangle. In these 45, 45, 90 special right triangles, these sides are going to have a special relationship. So if each of the legs is x units long, then the hypotenuse will be x times the square root of 2 units long. Okay, and that is our special ratio that we have in these types of special right triangles. So today's lesson is going to be going back and forth between being given a leg and trying to find the length of a hypotenuse, or being given the length of the hypotenuse and trying to find the two legs. Now, the way that I remember this is by using these little wheels. So I have a leg and I have a hypotenuse. If I'm given a leg, and I'm going to draw this arrow here, and I'm trying to find the length of the hypotenuse, I am going to multiply that length by the square root of 2. Okay? If I am given the hypotenuse and I am trying to find the leg, so I'm going in this direction of my wheel, then I'm going to divide the side of the hypotenuse by the square root of 2. Okay, so again, if I'm given a leg and I'm going to my hypotenuse, I'm multiplying by the square root of 2. If I'm going from my hypotenuse to my leg, I'm going to divide by the square root of 2. Okay, so let's look at some of these examples. In number 1, I'm going to look to solve for x and y. So I'm going to label these as my legs. I'm going to label my legs with an L and my hypotenuse with an H. So I am given one of my legs. Now I know that this is an isosceles triangle, so those legs are going to be congruent. So in this case, I know that x also has to be equal to 6. And if I'm given a leg and I want to find the hypotenuse, I'm going to multiply by the square root of 2, and this is just going to simplify to 6 times the square root of 2. Okay? Now, for number 2, I'm going to look at my triangle. I'm going to label my legs and my hypotenuse. So I'm given the hypotenuse, so 8 times the square root of 2. And if I look at this wheel, if I'm given the hypotenuse, I want to go to the leg. I'm going to divide by the square root of 2. Okay, now we have to remember those radical properties here. When I have the square root of 2 divided by the square root of 2, those are going to cancel out. And both of my legs here are simply going to be 8. Okay, so let's try a couple more examples. In number 3, again, I'm going to label my hypotenuse, my leg, and my leg. Right, so right away I can see that x is a leg. That's also going to be equal to 4. And my hypotenuse, I'm going to take 4 and multiply that by the square root of 2. Here, there's really nice to simplify. It just becomes 4 times the square root of 2. Okay, again with number 4, label your sides. All right, so I have 12 times the square root of 2. I'm going from my hypotenuse to my leg. So I'm going to divide by the square root of 2, and I get 12 for both of those legs. Now, this lesson is going to get a little bit heavily involved with radicals. So we have to remember those radical properties. If I look at something like number 5, I'm given my hypotenuse and I want to find my 2 legs. So I'm going to take that hypotenuse 28 and I'm going to divide by the square root of 2. Now, you cannot leave your answer with a radical in the denominator. So we rationalize our denominator. So I'm going to multiply the numerator and denominator by the square root of 2 here. This square root of 2 times the square root of 2 is equivalent to 1. So I'm not changing the value of this at all. So in my numerator, I have 28 times the square root of 2. The square root of 2 times the square root of 2 is the square root of 4. And I'm just going to keep simplifying from here. So 28 times the square root of 2 over the square root of 4 is simply 2. And now here, I'm going to divide the numbers outside of my radical. So 28 divided by 2 is 14. And then I'm left with that square root of 2. So both of my legs is going to be 14 times the square root of 2. Okay, again, this process is called rationalizing the denominator. We do this because we're not allowed to have denominators or radicals in our denominator. Okay, so number 6, we have our legs, we have our hypotenuse. If you're given one leg, the first thing you want to do is find the other one. So that other leg is going to be 3 times the square root of 2. If I'm given my leg and I want to find my hypotenuse, I multiply by the square root of 2. So 3 root 2 times the square root of 2. This is going to be 3 times the square root of 4. And the square root of 4 is 2. So 3 times 2 is 6. Okay, let's look at a couple more examples. Okay, so again, I'm labeling my hypotenuse, I'm labeling my legs. So I'm given that hypotenuse of 10. I want to find the legs, so I am dividing by the square root of 2. So here we're going to have to rationalize the denominators again. So multiply the numerator and denominator by the square root of 2. 10 times the square root of 2, and then the square root of 2 times the square root of 2 is simply 2. So this is going to simplify to 5 times the square root of 2. Okay, again, when you're dividing those integer values that are outside of the radical. All right, number 8, I'm given a leg and I want to find my hypotenuse. All right, so x is 2 times the square root of 5. I'm going to multiply that by the square root of 2, and I get 2 times the square root of 10. Okay, so my numbers inside the radical is going to get multiplied together. I can't simplify that square root of 10, so I leave that as is. Okay, number 9, I'm given a hypotenuse. I want to find my legs. So again, I divide by the square root of 2. Okay, now here I have these two numbers inside my radical. So those can be multiplied. 6 divided by 2 is 3. So this is going to simplify to 3 times the square root of 3. All right, number 10, I'm given a leg. I want to find my hypotenuse. So 5 root 6 times the square root of 2. We're going to get 5 times the square root of 2, or 5 times the square root of 12. Now, this square root of 12 can be simplified. All right, this is 4, the square root of 4 times the square root of 3, which is 5 times. The square root of 4 is simply 2 times the square root of 3. And my numbers outside of the radical can be multiplied together. leaving me with 10 times the square root of 3. All right, let's try a couple more of these basic diagram problems. I'm given my hypotenuse and I want to find my two legs. So again, if I'm given my hypotenuse and I want to find the leg, I'm going to divide by the square root of 2. All right, I can divide these. All right, I don't have to rationalize my denominator because I have a radical in the numerator that I can divide by. So here I'm going to get 6 times the square root of 5 for both of those legs. And for number 12, I'm given a leg. I want to find the hypotenuse. So I'm going to multiply by the square root of 2, leaving me with 4 root 6. Okay, now let's try some word problems here. Okay, for number 13, it says find the length of the diagonal of a square with sides that are 5 inches long. So I have a square, I'm going to draw that here. The sides are 5 inches. All right, and if I draw that diagonal, I see that this is making a 45, 45, 90 triangle. Okay, so I have my two legs that are congruent because this is a square. So I'm trying to find my hypotenuse. So x is going to equal the leg times the square root of 2, which is just 5 root 2 inches long. Now, I know with word problems, usually we like to keep our answers as decimals, but because the whole idea with these 45, 45, 90 triangles is to keep our answers as exact values, we're going to leave our radical answers here. Now for number 14, it's giving us the diagonal of the square. So it's telling us the diagonal is 7, and we want to find the perimeter of the square. Right, so again, we have a square, we have our 45, 45, 90 triangle. So if I'm given the hypotenuse and I want to find the leg, all right, or one of my sides, I'm going to call that x. So x is going to equal that diagonal divided by the square root of 2. So I'm going to rationalize my denominator, and I get 7 root 2 divided by 2. Okay. Now, this looks pretty messy. This is one of my sides. All right. I know if I want to find the perimeter of a square, I'm going to take that one side length, so 7 root 2 divided by 2, and multiply that by 4 because we have 4 sides. So this is going to cross out. 4 over 2 is just 2. And I'm going to have 2 times 7, which is 14, root 2 meters as my perimeter. 15 is giving me, again, the diagonal of a square. So the diagonal is 14 centimeters. And instead of finding the perimeter, we want to find the area. Now, in order to do that, again, we do need to know the side of the square. So I have my 45, 45, 90 triangle. I want to find the side. So if I'm given my hypotenuse, I want to find a leg. I'm going to divide by the square root of 2. Again, here we need to rationalize our denominator. We don't have a radical in the numerator that's divisible by that square root of 2. So I'm going to have 14 root 2 divided by 2. 14 divided by 2 is 7 times the square root of 2. If I want to find the area of a square, the area is my side squared. Okay, now I have to be careful here because when I'm squaring this side length, I'm going to square that 7 and I'm going to square that square root of 2. So 7 squared is 49 times the square root of 2 times the square root of 2, which is 2. and my area is 98 centimeters squared because we are talking about area. And for our last problem, all right, I have another square. Here it's telling me that the area of this square is 121 inches squared. So my area is equal to a side squared, and that area is 121. So I know my side has to be 11 inches. So if my side is 11 inches, I want to find the length of my diagonal. I am given the leg. I want to find my hypotenuse, and that is going to be 11 times the square root of 2 inches long. Okay. Now that's it for special right triangles, our 45, 45, 90. All right, so again, if you are given the leg for a 45, 45, 90 triangle, you're going to multiply by the square root of 2 to find the hypotenuse. If you are given the hypotenuse, you are going to divide by the square root of 2 to find the leg. All right, and we use these ratios here to get exact values for each of these sides. These work for any 45, 45, 90 special right triangle or any isosceles right triangle. Thank you so much for watching. If you have any questions, you can comment below. Thank you.